Welcome to the fourth and final exercise of this week's exercise in our course Competition Policy and Strategy. In this exercise 8.4 we are going to adjust the model we were discussing throughout this whole exercise or this whole assignment quite drastically. It's a very minor adjustment, but it changes its impact on the result couldn't be any more drastic. But because what we are doing is we are now considering the same demand function, the same cost function, everything stays the same, but now firms are competing in prices, or in other words, we are looking at the Bertrand competition model instead of the Kono competition model, which we were discussing throughout this whole exercise up until this point. We are still in a world with repeated interactions though. All right, so in this exercise, in this final exercise of assignment 8, there is now 8 companies in a Bertrand competition. And the first part we are going to do is we calculate profits in competition, profits under collusion, so competition, collusion, and profits under deviation from collusion. And then we want to finally answer the question, what is the short-term incentive to deviate? And of course, at this point, we know that this is simply the difference between the profits under collusion and the profits under competition. All right, let's start with profits under competition. Because in this very simple Bertrand competition model where we have 2 symmetric firms and 1 homogeneous good and so on, the result will be the Bertrand paradox. So under competition, both firms have exactly 0 profits. The profits under collusion we already know from earlier, because no matter if the firms would compete in prices or would compete in quantity, if they choose to not compete at all, they still behave as if they were one single identity or a monopolist and choose the profit maximizing price quantity combination in this market. So profits under collusion do not change at all. We still have the total profits of the monopolist, so 2,500, divided by the number of firms that participate in the cartel. Now, profits under deviation become slightly different because the best response function in the Bertrand model is slightly different than it is in the Kono model, right? Because in this case, the best response under competition in Kono, the best response under competition in Bertrand competition would be to ever so slightly undercut your competitor. Remember, as soon as the price is marginally lower for one firm, this firm will attract all the consumers by assumption. So, the profit maximizing strategy under deviation is ever so slightly undercutting prices, and because epsilon is marginally small or infinitesimally small, we can simply assume that the profits under deviation are basically the same as they were for the monopolist. So in this case, the deviating firm is making the complete monopolist's profit, which you already calculated. They are 2,500. All other firms in this case, by the logic of the Bertrand competition model, make 0 profits. So we could write pi f equals 0. All right. Now we are now asked to consider the critical discount factor delta crit for the case of a duopoly, all right? So we know there's n equal 2 firms in the market, n equal 2, and now we're asked to find the discount factor. And of course we know discount factor comes from comparison of the long run profits comparing the long run profits from deviating with the long run profits from collusion, right? So let's compare these two. We have stated the formula for the critical discount factor in the previous exercise, so let's simply use it at this point. we know if we start from this expression and we plug in the functions for the present values, which of course present values are a function of the individual or of the profits within each single period, and the discount factor the firms need to consider. If we now plug in these formulas and rearrange the statement, we have shown in the previous exercise that we can restate the critical discount factor to be equal to this expression, where we have in the upper part of the fraction the deviation profits minus the collusion profits, and this is divided by the difference between the deviation profits and the profits under competition, in this case of course Cournot competition. So we know all of these numbers. We know the deviation profits were 2,500, the collusion profits were 2,500 divided by 2, because there is only 2 firms in the market, and we know the profits under competition are 0. All right, we can plug in these numbers and then simplify the expression, and we find out that this is the critical discount factor. So in order for the collusion to be stable, the discount factor has to be smaller than 0.5, which implies that the critical discount factor is equal to 0.5 in this Cournot model. What we saw earlier in exercise 8.2 and 3 was that the critical discount factor in the same model, so same demand function, same cost function, and so on, everything stays the same, but in a Cournot competition model was slightly higher. It was 0.53 approximately. So what is the reasoning behind this? Why did the critical discount factor change? What determines the critical discount factor under Bertrand competition? Well, one part is that in Bertrand competition, the long-run reduction in profits is rather extreme, because going from collusion, where all firms share the monopolist profits, firms are going towards Bertrand competition, where there is 0 profits. So the long-run reduction in profits is quite extreme. That's the first part. This, of course, would imply that the punishment for deviation, the loss in long-term profits, if this is very large, then the punishment for a deviation is quite strong. So this would deter firms from deviate. However, at the same time, at the same time, we see that under Cournot, even under competition, firms are making positive profits. So this reduction in profits that results from the Grimm trigger strategy is not quite as stark in the Cournot competition. At the same time, we see that the short-run deviation profits are larger in the Bertrand model as well. So the short-run incentive to deviate is stronger in Bertrand competition than it was under Cournot competition. All right? So if we were to compare the short-run incentive to deviate with the long-run punishment to deviate, we see that both are larger in the Bertrand competition. There's a stronger short-term incentive to deviate, resulting from this marginal undercutting and making monopolist profits. And there is a stronger reduction in profits in the long run as well, resulting from the fact that in a Bertrand competition model, firms make 0 profits, whereas in the Cournot competition model, firms make positive profits. All right, so both sides of the inequation actually increase, so the direction, therefore it's not immediately clear whether or not collusion should be more or less stable in a Bertrand competition.